Alright guys, welcome to Systems Day 2. We're going to continue looking at graphing, but we're going to look at special situations where weird stuff happens and kind of how we answer those, what we do with those. So with this bell ringer, I want to start with going over parallel lines. Kind of what are they? And parallel lines are two lines that run side by side, but they never touch. The best way to think about this is railroad tracks. Railroad tracks go and go and go and go, but they never cross. They run right next to each other. So it says parallel lines have what kind of slope, and they have the same slope. The reason they have the same slope is they have the same rise over run. So we need to make a connection there that when we have the same rise over run, we also have the same slope, and that is called parallel. So if we think about this, if I went rise, run, these lines would have the same rise and the same run because they are running parallel to each other. The second part of the bell ringer is a review, guys. They want to know, is this ordered pair an answer of these two equations? So they're going to give me one equation here, a second equation here. They're going to give me an x equals 3 and a y equals -1, and they want me to plug this in. They want to see, hey, does this give me a correct answer or an incorrect answer? So for this top one, guys, for the x, we can plug in a 3 minus 2. For the y, we can plug in a -y, and they want to say, does this equal 5? If we put this in the calculator, guys, it does come out to 5 equals 5, so this top equation is good. For this bottom one right here, we would have our 2. For the x, we would plug in a 3 minus our y, we would plug in a -1. They want to know, does this equal 7? If we put this in the calculator, 7 does equal 7. This one is good. So whoever solved this problem did a correct and good job. 3 comma -1, or x equals -3 and y equals -1, works for these two equations. So moving into the actual notes for today, we are going to look at, can a system of equation have no solution or infinite many solutions? Obviously, we can have a solution. We did that yesterday, and we just went over that on the bell ringer. But what happens if weird things happen? So we're going to see one of those weird things here in example 1. I want you guys to note that this first one is already in y equals mx plus b for me. So I can say that the invisible number in front of x is 1 over 1. So my rise over my run is 1 over 1, and then the -1 is going to be my start on the y-axis. So if I look at this, I can go down to -1. My rise over 1 is 1 over 1. We are going to have a whole bunch of dots on this graph, and we can follow this in the other direction and put all of our dots. And I know I'm going a little quick here, guys, but this part should be a review from the last 2 days. For this bottom one, we have to put it in y equals mx plus b. To save us some time, I'm going to go ahead and just do that for us. When we do this, we're going to end up getting y equals 1 over 1x, and then it is plus 2. So on this, my 1 over 1 is my rise over run, and my 2 is the start on the y-axis. So I'm going to start up here at 2 on the y-axis. My rise over run is going to be 1 over 1. So once again, I'm going to have a very large amount of dots here. And I can follow this in both directions. And just like the bell ringer, we should be noticing right now that these are parallel lines. Are these ever going to touch? And the answer is no. It doesn't matter how big my graph is. So what's the solution? Well, our solution is when I would circle something in green. But I can't circle anything in green on this problem because nothing overlap, so there are no solutions. There are no answers in this problem. So they want us to compare the slopes. They want you to see that they are both 1 over 1. And with that, here's the key. Make sure that you are thinking of those slopes as being the same. Then it says compare the y-intercepts. Well, on this, one of them is -1, and then the other one is positive 2. So the key thing on this, they want you to think of this as they are different. All right, tomorrow we will use that same and different. Today we're going to mainly be visually looking at this. Tomorrow we'll more mathematically look at it. But guys, if you get two lines, they never touch, they are called parallel, your answer is no solution. So let's look at another example, example 2. What if they give us these two problems? Once again, guys, I want to save us some time. So I'm going to just automatically write down what these turn into. Turns into y equals 2x plus 3. We can put a 1 underneath there. And then on this second one, it turns into a y equals 2x plus 3 as well. So I'm going to put the 1 underneath there. So going back to our first one, our 2 over 1 is our rise over run. Our 3 is the start on the y-axis. So I can go ahead and graph that. Start at 3. I need to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. I can follow this pattern backwards to put my dots all the way across the graph. So when we look at our other one, our 2 over 1 is also going to be the rise over run, and my 3 is going to be the start on the y-axis. So I'm going to start at 3. Well, right away I start, and I've already hit 2 dots. Then I go up 2 to the right 1. Well, I hit again. And then I go up again, and well, I hit on both of those as well, so I got to circle those. Then I follow the pattern in the other direction, and I hit. All of these. Hit on every single one. I circle every single one of these. Guys, if we made the biggest graph in the world, every single point would hit, every one of them. So if every single point is hitting, then we have infinite many solutions. Forever we have solutions. So on this, guys, we can write down that we have our infinitely many solutions. And as usual in math, guys, we like abbreviations, we like shortcuts. You're not going to want to write that out every single time. So from here on out, you will write IMS. IMS stands for infinite many solutions. So it says compare the slopes, compare the y-intercepts. On this, we want to notice that the slopes are both 2 over 1, so they're the same. The y-intercepts are both 3, so they are the same as well. Alright, so let's go ahead and look at a third example. Let's get another graph going. And on this one, guys, once again, we're going to have to rearrange stuff just to speed up the notes a little bit. I've already done this, so this comes out to be y equals 2 over 1x plus 3. This other one comes out to be, put this down here, y equals 3 over 2x plus 2. So on this one, we have a rise over run of 2 over 1. Oops, let's see if I can do that correctly. The run goes on bottom. And then our 3 is the start on the y-axis. So I'm going to go up 3 on the y-axis here. I'm going to rise 2 over 1. I can follow this pattern the other direction as well. Put my dots all the way across. On this next one, I'm going to have my 3 over 2, which is my rise over run, and I'm going to have my 2, which is my start on the y-axis. So I'm going to go up 2. I will need to go up 3 to the right 2. Guys, be very careful here. These points get really close, but they do not touch up top. But then as we follow our pattern backwards, we do hit right here. And then I go down 3 to the right 2, I barely miss. Down 3 to the right 2, I barely miss. Down 3 to the right 2, I barely miss. This is why I like doing dots only, not connecting them. Some of them get really close, and when you do the dots, you will for sure see where your answers are. So it says, what's the solution here? Well, this is like yesterday. We are at -1 on the y, we're at -2 on the x. So we could say -2 comma -1. X equals -2, y equals -1. So this is what we've already done. I just wanted to throw it in there. And it says compare the slopes. When we look at the slopes here, they're different. We have a 2 over 1 and a 3 over 2 for the slopes. So they are different. And we have the y-intercepts. They're different as well. We have a 3 and we have a 2. So on this, guys, just because we've moved to a different set of notes doesn't mean we're going to forget about the problems that we did the other day. They will still be in there. So don't think every problem is going to be no solution or infinite many solutions. So guys, that finishes up our notes for today. Those are the 3 types of problems we can see. We introduced 2 new types, parallel, which is no solution, and then infinite many solutions where the lines are exactly the same. So be watching out for those. Don't think you made a mistake, and label your answers correctly. If you have any questions, you can ask me in class or work with somebody else in class to get this stuff figured out.